All right, so for 4A.3, we're going to talk about equilateral and isosceles triangles. We're going to start with isosceles. So that's when your two sides are congruent. So those two congruent sides are actually going to be called the legs. So those are going to be our two congruent sides. Okay, and then in our picture here, that's going to be AB and BC. Okay, so then we have our vertex angle. Okay, and that's going to be where our legs intersects. Okay, so in this case, our legs intersect at angle 1. So that would be our vertex angle. Okay, then we have the side opposite the vertex angle is going to be called your base. So the base of our isosceles triangle is going to be AC. So that's going to be the side opposite our vertex angle. Okay, so directly across from our vertex angle is going to be side AC. Okay, so then we have our base angles. So those are going to be our two angles along the base. So basically just anything but your vertex angle. So in this picture, it's going to be angle 2 and angle 3. All right, so then we have our isosceles triangle theorem. Okay, so what that says is if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So let's refer to our picture above, right? So if AB is congruent to BC, so those are our two sides, then it says our angles opposite those sides are congruent. Okay, well, so opposite BC is angle 2. Opposite AB is angle 3. So we would say angle 2 is congruent to angle 3. Okay, and then the converse of that is true as well. And remember, converse just means you switch your if and your then. So if two angles are congruent, so if our two base angles are congruent, so let's say if angle 2 is congruent to angle 3, then the sides opposite those are going to be congruent. So then AB would be congruent to BC. Okay, so let's see how we can use this to find some missing measures. So if we look at angle 1, okay, here is an isosceles triangles. It tells us the sides are equal, so the angles opposite those sides are going to be equal. All right, and then that just becomes basic algebra, right? So we subtract 5x, I get 3x. Add the 30, I get 39. So I get 39 equals 3x divided by, and I get x is equal to 13. Okay, if we look at something like example 2, okay, this one is the opposite. They tell me the angles are equal, which tells us that the sides are going to be congruent. So again, I set them equal to each other. All right, so I'm going to subtract 15x, I get 8x. I add 17, I get 24. So x is going to be 3. Okay, so basically this is an example of the theorem. And then number 2 is an example of the converse of the theorem. So saying it forward, also true saying it backwards. Okay, so if we look at number 3, it says in triangle RST, if ST is congruent to RT, okay, then the measure of angle R is equal to 9x plus 2, measure of angle S is equal to 13x minus 18, and then the measure of angle T is equal to 17x plus 1. Okay, the best thing to do on these types of problems is draw a picture. Okay, so here's our isosceles triangle. Okay, we know that ST is congruent to RT. So since they both share the letter T, I know that T has to go on top. Okay, well I know angle R is 9x plus 2. Angle S is going to be 13x minus 18. And then angle T is going to be 17x plus 1. Okay, so our base angles are going to be the ones that are congruent. So R and S. So I have 9x plus 2 equals 13x minus 18. So I subtract 9x, I get 4x. Add 18, I get 20. So x is going to be 5. Okay, now the other part of the question does say to find each measure. So to find angle R, we just plug it in. So 9 times 5 plus 2 is going to be 47. All right, and I know angle S is going to be the same thing because those are congruent. So S is also 47. And then T, we do have to plug that one in. So 17 times 5 plus 1 is going to be 86. Okay, I'm going to let y'all try number 4. So go ahead and pause it and give number 4 a try. Okay, so for number 4, your triangle picture, okay, should look like this with F, sorry, wrong letters, hold on, with W at the top. All right, and then we should have gotten X is equal to 23, W is 24, and then X and Y are both going to be 78. All right, well, that's isosceles. So let's go ahead and look at equilateral. Okay, a triangle is going to be equilateral if and only if it is equiangular. Okay, so we've heard that if and only if before. That's our biconditional. So let's go ahead and break it up. So basically what that is saying is that if angle A is equal to angle B, which is equal to angle C, then you can say the sides are congruent. So then AB would equal BC, which would equal CA. Okay, and then we can also say it the other way. So we can say if the sides are equal, then the angles are equal. Okay, and one thing that we know about equilateral triangles / equiangular triangles is since all 3 of these angles are the same, they all have to be 60 degrees for it to equal 180. So no matter what, anytime you have an equilateral, equiangular triangle, they have to have 60-degree angles. Okay, so if we look at example 5, we just kind of want to fill in what we're missing. Angle C is going to be 60 degrees. Okay, that's my missing angle. And then all my sides are the same, so those are all going to be 9. Okay, number 6, same kind of thing. All my angles are missing, but I do know that they are all going to be 60 degrees. And then same thing, I know all my sides are the same length, which is 24. Okay, then if we add in a little bit of algebra, okay, so I have one where I want to find my x's and find my y's. So first thing I notice is that they tell me that angle R is equal to 7x minus 3. Well, since this is an equilateral triangle, I know angle R has to be 60 degrees. So then that I can solve. So I add 3, I get 63 is equal to 7x. So x is going to be 9. Okay, so now for the y's, I have a couple of options of what I can do. All the sides are the same. I just need to pick 2 sides that are the same, or that to solve for. So it doesn't matter which 2 you pick, you're going to get the same answer. Okay, so I'm going to start by subtracting 9y. I get 2y. Add 23, so I have 2y equals 24. So y is going to equal 12. All right, and that is it for 4A.3.